and welcome to physics class on friction, its types and ways to reduce it. In this topic we will try to discuss about what is friction, how many types of frictions are there, and we will try to find out the ways and means to reduce friction. And before that we will also try to learn about the angle of friction, angle of repose. So let's go through the topic of this friction. Now, what is meant by this friction? Friction is nothing but this is the opposing force that is experiencing in between the two surfaces in contact when one body moves or slides or tend to move or tend to slide over another body. So we can define friction as the opposing force which always acts tangentially between any two surfaces in contact whenever there is a relative motion or tendency of relative motion between them. Now, this frictional force always acts between the two bodies whenever they tend to move and depends upon the nature of the surfaces in contact. That means the nature of the surfaces in contact means the state of roughness of the two surfaces, or rather you can say the state of roughness of the two surfaces in contact. Now let's see what about these causes of friction. You know, there are two views about these causes of friction. The one that is old view, and then another one is what is known as modern view. In the olden view, it was thought that this friction is due to the interlocking of elevations and depressions in the two surfaces, in the two surfaces in contact. That means on the two surfaces in contact, I should say. So what happened when we look upon to the surfaces through a powerful microscope or a sensitive microscope, then we may see that there are lots of protrusions, rather elevations and depressions. And when one body is placed above the another body, this interlocking of these depressions and elevations takes place in between the two surfaces, and just to overcome those interlocking of these elevations and depressions, we require some additional force. And so we, in the olden days, they thought that the friction is due to this interlocking of these elevations and depressions. Now this was discarded, and in the modern view it has been said that these causes of friction is not due to these elevations and depressions interlocking, rather it is due to the interatomic or intermolecular force of attraction between the two surfaces at the point of contact. Now actually, when we take it at two highly smooth flat surfaces, just like that of a glass, plain glass, I should take it, the plain glass, when one plain glass is placed above the another, and when you try to pull, or whenever you try to have a relative motion in between the two plain glasses which are kept in contact, it is very difficult to even move or slide one plain glass over the another, even though there is no interlocking of this depression and what elevations. What happen, there is a large frictional force in between the two plain smooth glass, and it is due to not the interlocking of these elevation and depression, rather it is due to what, interatomic or intermolecular force of attraction between the two plain glass surfaces. As it is flat enough, smooth enough, what happened, the point of contact of one molecule and another molecule of the two surfaces, it increases. And so what happened, in order to overcome this intermolecular force among the two molecules of the two surfaces in contact, we require additional force that is known as what, frictional force, right? Now let's see about that this friction is a self-adjusting force. You may be asked, friction is self-adjusting force, and you may be asked to give the what this as a question. You may be asked to give your own view to what supplement this statement. It may be asked like that also. Now this friction, okay, there are two types of friction. The first one is static friction and another one is kinetic friction. Kinetic friction is also known as dynamic friction also. Now before that, what limiting friction, we need to know what is meant by limiting friction. Now actually when the body is placed over another surface, and if you keep on increasing the applied force, the body may not move. Okay, so before actually move the force, okay, the applied force is what adjusting its frictional force. That means your frictional force also adjusts with that of the applied force. If you keep on increasing here in this diagram, it increases from 2, 2.1, 2.2, 2.3, 2.4 until it reaches 2.6. The body doesn't move. So what happens when the body is applying with the increasing force, your frictional force will also increase correspondingly. So that force of friction that arises before the body actually moves or slide over another body, we call it that type of friction as static friction. Okay, so the maximum static friction, okay, before which the body doesn't move, if the applied force is more than that of the maximum force, what we call as limiting friction, then the body will start its motion. That means the maximum static force, okay, that is known as limiting friction. That means limiting friction is the maximum static force below which the body doesn't move, above which what happen, the body start its motion, which is okay, when placed over another surface. Got it? So it will be seen here. So before that limiting friction, before reaching this 2.6, okay, applied force 2.6, what happened, the force of friction, that 1 newton, 2 newton, 2.5 newton, these are all static friction. But as soon as when it reaches 2.6, what happened, the maximum value of static friction, then the body start its motion. So what happened, that 2.6 here in this example is nothing but this is the limiting friction. So that is also given here in the definition. The maximum value of force of friction, rather the static force of friction, which comes into play before a body just begin to slide over the surface of another body, is called what, limiting friction. Got it? Yes. Let's see. So within this limiting friction, why the body doesn't move? Because the frictional force adjusts itself with that of the applied force. So it is also said here in the last sentence, within the limiting friction, the force of friction always adjusts itself equal to the applied force. That is, as much force of friction comes into play as it is just necessary to prevent the body from moving. That means before limiting friction, if you keep on increasing the applied force and before reaching the limiting friction, what happened, the force, okay, acted onto the body, that means applied force and the frictional force, they balance each other. So what happened, when the applied force increases, your frictional force also increases correspondingly. That is what it is said that friction is self-adjusting. What type of friction? Your static friction. Got it? But as soon as the body starts its motion, what happened, there is friction, no doubt, in between the two surfaces in contact. When the body actually moves also, there is a friction in between them, and that type of friction, when the body actually starts its motion, okay, or whenever there is a relative motion in between the two objects, that type of friction, when the body actually starts its motion, is known as what, kinetic friction, or this kinetic friction is also known as what, dynamic friction also. Got it? That is what it is said here. So let's see about the next one, static friction and kinetic friction. As I said also, okay, earlier, that the force of friction within the limiting friction is called what, static friction. That means that is the force of friction that comes into play between the two surfaces in contact before the body actually starts moving, right? It will be also seen here in the graph. If you are drawing the graph between the force of friction and that of the applied force, what happen? If you keep on increasing the applied force, then what happen? The force of friction also keep on increasing. Suppose if your force of friction, okay, I mean if your applied force is somewhere here, then what happen? The force of friction will also correspondingly increases. Suppose if your applied force is somewhere here, then your force of friction will be also coming here at this point. Got it? If your applied force increases from here to here, that means your force of friction will also increase from here to here, like this. Got it? So what happen if you keep on increasing the applied force, then the corresponding force of friction will also increases. Got it? So the applied force that is, okay, having here at this point somewhere here, at that time what happened? This is the maximum force of friction. So this maximum force of friction, we call it that force of friction as limiting friction, and this force, applied force, and this limiting or the maximum force, static force, we call it this as limiting force of friction, and it will be given by this, okay, limiting friction FL. This means here this will be your FL. Got it? What is known as limiting friction? Limiting friction is what? Maximum static friction. So those friction, okay, when you applied this, when you increase the applied force from here to here to here up till here, okay, what happened? The body doesn't move. That means this applied force will be equal and opposite to that of the force of friction. When you increase this also, your force of friction will also increases correspondingly likewise. So that means up till this applied force, what happen? When the applied force is less than this limiting friction, rather for the body to start its motion, then those applied force will be equal and opposite to that of the static friction. Static friction means what? The body doesn't start its motion. That means the body doesn't actually starts moving over another surface. Okay, that type of force of friction which arises in between the two surfaces in contact, when the body actually starts moving over another body, that type of friction we call it as static friction. So this static friction will be shown with this graph. It is a straight line having some slope. That means what happened? Corresponding to that of the applied force, your static force will also correspondingly increase. But as soon as you reach this maximum, what? Limiting friction or static friction, we call it as limiting friction. So maximum static friction, we call it as limiting friction. As soon as it reaches this, and if you apply a little bit more than this applied force, okay, corresponding to that of the limiting friction, then what happened? The body starts moving. So when the body starts moving, that type of friction that arises, we call it that friction as kinetic friction. Okay, so your kinetic friction is denoted by Fk, and this kinetic friction is less than the static friction. You see, this is the friction for kinetic, that means dynamic friction or kinetic friction. So when we see this kinetic friction, your kinetic friction is less than that of the limiting friction. Got it? So as soon as the body starts moving, what happen? The amount of the static friction or limiting friction, okay, is less. Okay, the amount of limiting friction, or rather the amount of friction I should say, what we call as kinetic friction or dynamic friction, is less than that of the maximum static force. Got it? So it will be easier to move. Okay, as soon as the body starts its motion, then it will be easier to move. Why? Because the friction that arises when the body starts actually its motion, the friction is less. So that type of friction when the body actually moves over another surface, we call it that type of friction as what? Kinetic friction. Now see, here in the diagram, OA represents what? Your self-adjusting nature of the force, that is static friction. That means as the applied force increases, static force or your force of friction will also correspondingly changes or increases. Okay, and FL is what it is known as the maximum static friction, and we call it FL means limiting friction. Okay, so that limiting friction will be obtained from here. That means the highest point for the static friction, we call it that as what, limiting friction in the graph. Okay, and you will see there the kinetic friction as soon as the body, okay, starts what, moving or sliding, then what happen, the friction that arises in between the two surfaces in contact, we call it as that kinetic friction. Okay, kinetic friction or dynamic friction. Okay, yes. Now let's see about the laws of limiting friction. Now when we say about the laws of limiting friction, it is nothing but this is the law governing about that of the what, friction in the case of what, your limiting friction. That means the maximum static friction. The magnitude of the limiting friction between any two surfaces in contact is directly proportional to the normal reaction between them. Suppose if a body, okay, lies over a table like this. Okay, this is a flat table, you take it this as a flat table, and an object is placed over here. Okay, then what happen, weight of the body will be acting vertically downward, and if m is the mass of the body, okay, m is the mass of this body, then its weight w will be equal to mass into acceleration due to gravity, right? And perpendicular to this surface, okay, perpendicular to this surface, the body, okay, when placed over this flat surface, the body neither moves downward nor it flies upward, right? So what happened, it is because of what, there is another reaction. If you take it this as an action, then by Newton's third law there will be equal and opposite reaction. So that reaction perpendicular to the surface, okay, we call it that as normal reaction, and it is denoted by what, capital R. It is normal reaction. Normal, why? Because it is perpendicular to the surface. Got it? So what happened, that normal reaction is denoted by R, and what happened, as per this laws of limiting friction, your frictional force or limiting friction, the magnitude of the limiting friction, I mean, it is directly proportional to what, this normal reaction. Got it? And if you want to change this proportionality into equality, then we require a constant. That constant we call it as what, this constant is known as coefficient of limiting friction. Got it? Coefficient of limiting friction. So if one asks you what is meant by coefficient of limiting friction, then you can just what, answer it, reply it as what, it is the ratio of the limiting force of friction to its normal reaction. Got it? So this frictional force and normal reaction, these are all of the same unit, and so your coefficient of limiting friction doesn't have any unit, right? Now the direction of the force of limiting friction will be always opposite to the direction of the motion. Always opposite to the direction of motion. Got it? Or in will be opposite to the direction in which the body tend to move. Got it? This is a nature for the direction of the friction. Whenever we say friction, it is the opposing force, so it will be always in the direction in which the body moves or tends to move. Got it? Yes, the limiting friction depends on the material and the nature of the surfaces in contact and their state of roughness. It depends upon the material. Okay, if the material is smooth enough, okay, or whether it is rough, what type of material, okay, whether it is a wood, iron, got it, it depends upon that material and also the nature of the surfaces in contact. That means the state of roughness, whether it is smooth, rough, okay, it depends on it also. Now another one is that limiting friction doesn't depend upon the area of contact, okay, so long as the normal reaction remains the same. Now in the case of the brick, okay, brick, you must be knowing that brick, okay. Now if you are taking that brick, okay, whether you are keeping onto the flat surface, okay, whether you are keeping flat like this, okay, flat like this, the weight will be what? W, that will be equal to mg. Whether you are keeping like this, or if it is standing, if it is made to stand, that brick like this, got it? Or if you are keeping like this, okay, this is flat one, flat portion is here like this, got it? Just like you are keeping your instrument box on a table. If you are keeping like this, and if you are making to sit, okay, in this way, right? So the flat portion is where? The flat portion here, it is the larger area, okay. And if you are making stand like this, then what happen? It may be standing like this, or it may be in the shape of that of, say, I should not write this one. Instead of this, let me draw like this, okay. It will be easier to draw in this way. If it is flat like this, that means it is just like in the sitting position, okay, in this way. So what happened? The weight will remain same. This also will be equal to mg, right? This weight will be also equal to what? Mg. Am I right? That means the weight doesn't change. So what happened? Their normal reaction will also be remain same. Normal reaction will be also same, right? And this normal reaction R, the magnitude of R will be equal to nothing but it will be equal to mg, right? So your limiting force of friction or limiting friction, as it is directly proportional to R, and what happened? You see, it is all equal to normal reaction, okay. The area of contact here in the first case, this is maximum, okay, and this is least. In this case, the second one is the area of contact is least. Why? Because it is in the standing position, and now this is in the sitting position. This is in between, that means medium, you can say. The area of contact is medium in this case, okay. So what happened? Even though the area of contact are different, what happened? The force of friction remains same. So that is what it says in the last law, that limiting friction doesn't depend upon the area of contact so long as the normal reaction remains the same. Now let's see, what are the forces acting on the block sliding down a rough inclined plane? Let's take an inclined plane, okay, and you keep it a block of, okay, body onto this inclined plane. The angle that is having here, let's take it this as theta. This is the block of an object, okay, put on this inclined plane. This is a horizontal plane. Onto this inclined plane, what happened? You keep an object, and what happened? If you keep on increasing this angle, okay, if you keep on increasing the inclined plane from here like this, and it come to this plane, then what happened? This body will not be lying onto this inclined plane forever. If you keep on increasing this angle of inclination theta, then what happened? The body will surely slide, and the body slide with an acceleration a. Let's take it as a, okay. So in that way, what happened? Let's see what are the forces that, okay, are acting onto this block of this body. Now weight will be acting vertically downward, and we know that weight is equal to mass into acceleration due to gravity, where small m is the mass of this block of mass, okay. And another one, your normal reaction will be here, normal. Why? Because don't think that normal reaction will be opposite to the weight. It will be always perpendicular to the surface, where the body lie. Okay, so your normal reaction will be in this direction, perpendicular to this surface where the body lie, okay, or where the body is keeping. So what happened, your normal reaction will be here and your frictional force will be here like this. Why frictional force will be opposite to the direction in which the body moves? The body will slide down or move down. So against this direction of the motion of the block of mass, your frictional force will be here. So there are another two forces. One is normal reaction, and it may be denoted by small n, capital N, or it may be denoted by capital R also. Okay, and your force of friction will be here in between the two surfaces in contact and opposite to the direction in which the body is supposed to move. So what happened, we can mark it here also F, no doubt. That means this frictional force, it may be denoted by capital F also. In some textbook it may be denoted by small f, in some textbook it may be denoted by capital F also. Got it? So what happened, these three forces, one is what, normal reaction, which may be denoted by capital R in some textbook. Okay, it is matter of notation only, you can denote it by capital N or capital R, doesn't matter. So there are three forces acting on it. One is what, one is weight equal to mg, normal reaction, and what, your force of friction, right? Yes, let's see about the next one. What is meant by angle of friction and angle of what, repose? Now what is this angle of friction? Angle of friction is nothing but this is the angle between the resultant, okay, between the resultant of what, normal reaction, and the frictional force, okay, with the normal reaction. Now this is the flat surface and this is the block of mass. Got it? And so what happened, if applied force is acting onto this, that means the body will start moving along the direction of the applied force. Okay, so against this direction of the applied force, or along which the body tends to move, your frictional force will be opposite to it, right? So if this is the applied force, your frictional force will be acting along this, and your normal reaction will be perpendicular to the surface in which the body lie. Okay, so your normal reaction is here in this direction, so your frictional force is along this. So the resultant of this frictional force and the normal reaction will be in this direction by completing the what, parallelogram, you can say. Here in this case both are perpendicular, so you can say rectangle. Okay, so by completing the parallelogram, what happened, the resultant of this normal reaction and the frictional force will be in this direction, right? So what is this angle of friction? Angle of friction is nothing but this is the angle between what and what? Angle between S. What is this S? S is nothing but the resultant of the frictional force and the normal reaction, making with what? Making with the normal reaction. So it is the angle between the resultant of the frictional force and the normal reaction making with what? Normal reaction is known as angle of friction. Got it? Let's see the definition, right? Yes, this is the definition. Angle of friction may be defined as the angle between what and what, which the resultant of the limiting friction, or you can say frictional force, and the normal reaction. This is a resultant. Okay, S is a resultant of the limiting friction and the normal reaction max with the normal reaction. Okay, by definition, okay, angle theta is the angle of friction. And see, if you draw a rectangle, okay, if you complete that rectangle here, then what happened, you may find that this is what, this is equivalent to that of limiting friction F, right? Okay, and this is your normal reaction, right? So your tangent of theta will be equal to what? F by R. Got it? That is what it will be coming up in the next. Okay, your tangent of theta will be equal to what? F by r. Why? Because tangent of theta means what? It will be perpendicular or opposite to its base, right? So that is what it is having. So this F by r is nothing but this is the coefficient of what? Limiting friction or static friction, you can say. Not static friction, rather limiting friction, but that limiting friction, it is generally called as static. Okay, and so this what? Tangent of theta is equal to what? Coefficient of that limiting friction, right? So let's see about that of the angle of repose. And in the angle of repose, so let me show you the diagram first. Suppose if this inclined plane, okay, this is the horizontal plane and this is the inclined plane, and over that inclined plane a block of mass is kept on it, and so if you keep on increasing that angle of inclination of this inclined plane, then what happen? When it is the angle of inclination is small, then what happen? The body will not slide down. But that particular angle of this inclined place, inclined plane, okay, a block of mass placed over it just starts sliding. That angle of inclinations where the block of mass placed over the inclined plane just starts sliding, that angle we call it that as angle of repose. Can you get my point? Suppose if you keep on increasing the angle of inclination, at first the body will not slide down, but that particular angle of this inclined plane whereby the object placed over it just starts sliding, okay, that angle of inclination of the inclined plane where the block of mass placed over it just begin to slide down, we call it that angle as angle of repose. That will be also given here in the definition. Now it is just similar to like that there are the forces acting onto the block of mass placed on it. Now if you take it this alpha as the angle of repose, and the weight of the body placed on that inclined plane will be vertically downward, okay, this angle alpha and this angle alpha will be same, right? So what happened? Let's try to find out the forces that is acting onto this block of mass. As we have done in the previous slide, your body will tend to move downward, right? It begins to move down like this. So what happened? Your frictional force, okay, or static friction or limiting friction will be acting opposite to it, okay, opposite to the motion. So your frictional force will be upward like this. Your normal reaction will be perpendicular to this inclined plane. Got it? So opposite to it, what are the forces? Okay, let's see. These are the three forces: weight, frictional force, and then normal reaction. Now this weight, okay, we can resolve it into two rectangular components. One perpendicular to the surface, that means opposite to the normal reaction. Another opposite to the frictional force, that means downward like this. As this is having angle alpha, mg cos theta will be cos alpha will be there, because this angle is alpha. So mg cos alpha, okay, we call it this component as what? Theta component. But here as angle is alpha, we can call it as alpha component, and another one we call it as what? Perpendicular component or sine component, you can say. If angle is here, it will be always cosine, okay. So mg cosine of alpha will be there, and the another component, rectangular component, it will be mg sine of alpha. Got it? So what happened in the next case? Also it will be same as that one. It is done in the case of that of angle of friction. Now you see that these two are equal and opposite, and these two are equal and opposite, right? So in magnitude, what happened? Your Fs will be equal to mg sine of alpha, and your normal reaction, it may be denoted by small n or capital R. This will be equal in magnitude with that of the mg cos theta. It is given here. Now if you try to take the ratio of this F and R, you divide this equation, okay, the left hand side by the right side equation, so that it will be equal to Fs by R. So mg will be cancelled, and sine by cos will be what? Tangent of alpha. So your tangent of alpha will be equal to what? Fs by R, which is similar to that of the this one, okay, FYR. So what happened when we do the experiment, okay, very carefully, then what happened, this angle of friction and angle of repose are almost same, okay. So Fs by Fr will be what, tangent of alpha. Mu is equal to what, tangent of alpha. If this surface, okay, of the flat surface I mean, and this inclined plane, if the surfaces are same and the body are also same, then it is found that your angle of friction is equal to what, angle of repose. Both are mu, see, coefficient of what, limiting friction. So if tangent theta is equal to mu, we can also write here as tangent of alpha. So tan theta equal to tan alpha. So that means theta will be equal to what, alpha. That is what I said. Okay, angle of friction is equal to what, angle of repose. Got it? Now let's see some methods to reduce this friction. Now to reduce this friction, what happen, we need to have what, lubrication. Lubrication may be liquid, or it may be in the form of solid, or in the form of oil, okay. Whenever a machine is not working properly, then we usually apply what, some what, lubricating oil or what, grease, like that, right? The next one is what, streamlining. Streamlining means what, designing of the body, okay. And there is also another way of reducing what it is, by making a use of ball bearings, steel ball bearings, okay. I will show you one by one. And the next one is what, smoothening or polishing of the surface. So let's see about that of the lubrication first. Now to reduce friction, okay, we usually put some lubricating oil, okay, or wax or grease, for example, like this in the what, this gear system, okay. When the gear systems are moving one up, having that friction, if the friction is more, than what happened, there will be wear and tears of these what, gear system. So just to prevent those what, wear and tears, we usually have what, some lubricating oil, just to reduce the friction, okay. So it may be what, your motor oil or wax or grease, and it can be used with that of the solid what, lubricant also. Your graphite powder is one of the best material to use as what, as to reduce what, the friction, okay. And but here in this case of this gear system, in order to what, avoid that heating due to this frictional force, what happened, it is used with that of the motor oil, okay. But if you are using here that of the graphite, that means solid lubricant, then it will not work, okay. Why? Because heat may be developed more. So if you put what, your motor oil, then what happen, heat may be greatly reduced, okay. And the next one is about what, streamlining. You see here that when the car is moving at a very high speed, then this is the motion of the what, wind. Got it? So if it is flat enough like that of the bus, okay, then what happened, this, due to that friction, okay, this car cannot move at that much high speed. This is a racing car, okay. And you might have seen in almost all those high speed moving objects, okay, it will be pointed at the tip, okay, in the front, as just like that of your arrow, okay. It may be like that of the electric train or bullet train. It will be pointed, okay, it will be pointed at the tips like this. It may be also in the rocket also, okay. And it may be also in the that of the high speed aircraft, like that of a fighter aircraft, okay. You will see all those high speed moving objects, it will be pointed in the front, okay. That is just to reduce that friction while it moves what, in the air or in the water, even in the boat or ship also, the front part, or okay, that is pointed, okay. That we call it that as streamlining, right? And the next one is by using your ball bearings. You will see here some steel balls are there, okay, and this is for fixing the axle. Got it? And so what happen if it is used with that axle for rotation, then what happen due to the moving of these spherical steel balls here, we can call it them as ball bearings, and these are known as turning cylinders. So in between these turning cylinders, if this ball bearing is met, okay, by use of that of lubricants, then what happen, it can be rotated, okay, or it can be moved at a very high speed without having any friction. Got it? So in almost all the wheels of the vehicle, we use such types of ball bearings. Okay, it may be spherical or it may be also cylindrical. Okay, cylindrical ball bearing are also there. Got it? Cylindrical bearing, I should say, not ball bearing. Ball means spherical. Okay. So this is also one of the method to reduce what friction. And one way to reduce the friction is what, by using of rolling than that of sliding. Why? Because rolling friction is lesser than that of the sliding friction. So here you will see that rolling wheels here also in this parrot there are using some toy wheels there. Okay, so just to move it, okay, it will be easier to move. Got it? These are nothing but these are the ways and means to reduce the friction. Got it? And the last one to reduce the friction is smoothening or polishing of the surfaces. If the surfaces are rough like this on the right hand side, okay, then it will be what, having more friction. Why? Because we will require more force to move an object placed over it. Okay, and if it is smooth like this, then what happen, your frictional force will be less. So this smoothing or polishing of the surface is also one of the method or means to reduce friction. Now as I said, this friction, okay, it is a necessary. Friction is necessary, and at the same time it is also evil. So we generally say that friction is a necessary evil. And you may be asked by giving this statement and to write, okay, to write in support of this statement, you may be asked by giving you 2 marks or 3 marks also. Friction is a necessary evil. Now friction is necessary. If you are not having any friction at all, okay, in between your hand and your mobile now, whatever you are watching now, you cannot hold your mobile on your hand if there had been no friction at all. So due to that friction only you can hold your mobile at your hand. Okay, if you are not having any friction in between your hand and your pen, you can't hold your pen to write on your paper. And if there is no friction at all between the nip of that pen and paper you are writing, then you can't write it nicely. It may be slip away and you can't write it. You can't walk, okay, on the floor if there had been no friction at all in between your sole, okay, in between the sole, the lower part of your foot, and that on the ground. If there had been no friction at all, you can't walk it. It will be very slippery and you may fall down also while walking. Okay, why we sleep in the rainy season while we walk it in the muddy earth, because muddy ground, I mean, because there is less friction. If there is less friction, we can't walk it, right? So friction is necessary, right? And at the same time, friction is an evil. Why? Because due to that friction only there will be wear and tears of the objects. Suppose if there had been no wear and tears, whatever we are wearing our shoe, that will remain forever. Due to that wear and tears, because of this friction, there will be wear and tearing of the sole, just like that wear and tears of the tires of the vehicle. Okay, that is also a necessary, an evil. Due to that, what happened, we need to spend more money in buying it a new one, right? So what happened, if there had been no friction at all, whatever it is bought at the very beginning, it will be there forever, right? So it doesn't happen like that. Wear and tears of the material takes place because of the friction. So friction is said that it is a necessary evil, right? So now let's see which one is easier, whether it is pushing or pulling. First, let's try to see about that of pulling. Now onto the flat surface here like this, and block of a block of mass is placed over this flat surface, and by applying a force in this direction, a force is applied and the body is going to pull it, this block of mass. So now when force is applied here, then what are the forces that is acting onto this block of mass? Let's see. Let the mass be having small m, a capital M, so that its weight will be acting vertically downward, mg, like this. So your weight will be acting vertically downward in this direction. Okay, this will be your weight, which will be equal to what? Mg, like this, right? And this is the direction of the applied force, denoted by capital P. And let this applied force be, okay, applying onto the block of mass, making an angle theta. Okay, this angle with the applied force with the horizontal, I mean this angle is what? Theta here. Got it? So by resolving into two rectangular components, one along the horizontal like this, that is P cos theta, because this is a theta component and it will be always cosine theta, I told you. So P cos of theta here, and another component will be what? P sine of theta, perpendicular to it, that means in the direction of the normal reaction. So here in the normal reaction is denoted by what? Capital R. So what happened? Your one component, that means P cosine of theta, is in the horizontal direction, and in the normal direction there is another component also known as P sine of theta, where your P is applying here, making an angle with the horizontal, and in the vertically downward direction your weight mg is also acting downward. Got it? And your frictional force will be opposite to the direction in which the body is moving or tend to move. The body will move in this direction, so your frictional force will be opposite to it, and it is denoted by F1 here. Got it? So now let's see. Your this body, okay, block of mass which is placed over the another surface, this body, neither it jumps upward nor it moves downward, vertically downward. That means the total upward force is equal to that of downward force. So your upward force will be equal to what? Total upward force, it is R plus P sine theta, and in the downward direction it is only mg. Now let's try to express this R, the normal reaction, as equal to what? Mg. You transfer this to the left hand side so that it will be P sine of theta, like this, right? So this normal reaction is less than what? That of the weight, because we are going to subtract something from the weight. Okay, and so what happened? Your F1, as it is given by your laws of friction, that your laws limiting force of friction, F, is directly proportional to the normal reaction and will be equal to what? Mu times of R, right? So here your R is less in the case of pulling, but in the case of pushing, R will be more. Got it? R will be more. So what happened in the case of that pushing? What happened? Your frictional force is more, and so it will be easier to pull than that of pushing. Let's see. Got it? Let me erase it out, and then let's see for the second part of pushing. Suppose if it is going to push it, then your pushing force is in this direction, with pushing force is taken as P. Okay, your pulling force is also denoted by P here, and your pushing force is also denoted by P. So if you are going to push it, then what happened? It will be in this direction with that of the pushing force, and if that pushing force is applied to that block of mass with an angle theta with the horizontal, then this angle will be also theta, right? This angle, I mean, so this angle will be also theta. So we can resolve this P into two rectangular component, one along here, that will be cosine. Why? Because this is theta component, okay, with theta, so it is having theta, so your theta component will be what? P cosine of theta, right? Your P cosine of theta will be here, and this is not having theta, no theta here, so this will be what? P sine theta. And weight is acting vertically downward, no doubt, normal reaction upward. So the forces, okay, as the body is going to move in this direction, your frictional force will be in this direction, and it is denoted by F2. We want to compare it whether this F2 is more or F1 is more. Which one is more? The one, okay, with a more force will be what? Difficult to move. Lesser force, lesser frictional force means easier to move. So let's try to find out the frictional force in this case of pushing. So what happened? The total what? Normal reaction, okay, as the body neither what? Moves downward nor flies upward, the total force, okay, in the downward direction must be equal to that of the upward force. So your upward force is normal reaction, and your downward force is what? P, let me first write with that of the what? Mg first, okay, your weight mg plus, because they are acting in the along the same direction, so it will be added with P sine theta like this. So what happened? Your F, what is here? 2, this will be equal to mu, okay, times of R. So your mu times of R means what? The mg P sine of theta like this, right? So here in this case it is what? More than what? Your normal reaction is more than the weight. But in this case of that pulling, what happened? Your normal reaction is equal to what? Weight minus P sine of theta like this, right? So here it is added. Normal reaction is more in the case of what? Pushing. Normal reaction in the case of pulling is what? It is less than the weight, but here it is more than weight. So what happened? Your frictional force is more in the case of what? Pushing. So your pushing force here, it is greater than that of the friction in the case of pulling. So frictional force is more in the case of pushing means what? It will be difficult to move, and lesser frictional force means easier to move. That is what it is happening here. So as your frictional force is more in the case of pushing, it will be easier to pull. Got it? So with that, we will come to the end of our today's class. Thank you for watching my video. Got it?